All right, all right, all right, all right, all right, all right. So today we are going to be using just a 3D printer. We're going to create a new document in Onshape that's called double pendulum. If you don't know what a double pendulum is, just for backstory, a double pendulum is a very cool system where you have basically two masses connected together, and they create this very bizarre shape. Anyways, it's a chaotic system, and I feel like it would be fun to have a little desk toy that I can hit around. And so we're going to be just using a 3D printer and some classic skateboard bearings, 608 bearing. This is used all over the place. You can get them for 20 of them for $6, so anybody should be able to build this. And so we're going to just start by making some sketches, building the most simple prototype that's not beautiful, but it's functional. And so basically, we're just going to get started with that. So I think the way I want to do this, I always like the starting from the top plane and going up, but honestly, I don't think that I'm really that experienced. So let's see. Let's just make this 50 by 50. Okay, and then we're going to extrude this up by 5. Then what we want is so we're just going to get the shape down, and basically it's going to just look like a, if we just look at an image of pendulums, nothing looks quite like what if I look up desktop pendulum? Yeah, anyways, so just something that's like kind of cantilevered. Okay, so let's just, let's see, we want a center rectangle. Make it like this. It doesn't need to be this big. We can make this, so first off, this and this are vertical. So this can't move. So let's make this like 5. And then let's make this 15 and this. Or maybe we should actually delete this and we should just make this and this incident. All right, so this goes up. How tall do we want to make it? Now this is the interesting thing. If we make it go up like 100, that's kind of too tall for a desk toy, huh? If we make it go up 50 though, and then we do want to think about how it's going to be printed too. I think if we print on this back face, maybe it'll be all good. All right, so let's start with 50. And then sketch on here. Oops. Just make this 5. And we're going to actually, hold on. So the question is basically, okay, well, whether or not this connects to the OD or the ID. Let's make this, so hold on. Let me pull up the 608 bearing dimensions. I just always forget. Okay. 8, 22, 7. So we need this to be like 25. That's crazy. These bearings are so big. But I feel like you need bearings. Otherwise, it's going to be like lame to play around with. Wait, okay, if I just sketch on here, let's go back to the, okay, we are sketching right now. And I just make a circle that's like 30. Okay, so fuck it. Let's go big and let's make this extrude 100. Okay, now we want to modify this. Say what? Wait, there isn't. Okay. Oh, okay, wait. Let's delete this circle. What I'm thinking is we're going to, no, we want grip on the whole thing. Hold on, so let's delete this. We need to make a circle here. So, okay, so it needs to come out a little bit. So yeah, I'm gonna do this. And we just want it to come out maybe 15. It definitely doesn't need to be that, okay, now on here, let's see the wall. So we're gonna make this 22 plus 2 times 3. It doesn't need to be that crazy. So 22 is the outer. Okay. So now we can take this. We just extrude this. Oh, wait, but wait, we want. What's undefined here? Yeah, this only needs to be like 15, I feel like. So wait, what is it that I'm trying to even do? Let's sketch on here. Let's make this. Let's make. What are you? Okay. So. Let's just make another circle. This is going to be 22. Okay, right. So this is clearly not going to work because this whole base, it needs to connect to that. So why don't we make, okay, so let's go back to here, pretty sure it's this. We're going to make this 20. Okay, now we have just a tiny bit of grip on there, but that's obviously not enough. Oh. But I just want to see what it looks like. Obviously, we need to fix all this stuff, but let's just see what it looks like. So now we want to extrude this by 7, right? I feel like we could just make this, like we could put a back wall on here and we could extrude it to there. So why don't we do that? So we want to take this sketch again. We want to select this part, this part, this part, and this part. And we want to extrude it up to face here. And it's a merge with all. Why is it being so mean? Boolean operator in non-manifold geometry. Because of this thing? What if we did it up to... What if we just did it up to this face? Huh. Okay, I don't really know why that's... Oh, wait. You know what I have to do? I have to add... In here, I have to add this, too. Okay. I get it. Let me just go back to here. Okay. That actually doesn't look that bad. I mean, for me. I'm not the best designer. So now a bearing is going to go in there, and let's just... Should we just do it in place? We might as well, right? Oh wait, what is this? This is exactly 22. That should be fine. I don't want it to be super tight fixed. I don't think it needs to be. Maybe we could like, no, because I think I did a negative clearance of 0.2 mils, and it was like really tight. Like I need to get it in with a hammer, like a mallet. But I don't think I'm ready for that. So let's just make a new. I just want to do it in assembly. It's so easy to do this. All right, so this is gonna be and let's just make a variable. I don't need a variable studio, bro. All right, so this is gonna be here, 22. Okay, and this is going to be what did it say? 8? I think it's 8. Is that right? That doesn't look right. That's a freaking donut, bro. Seriously? Let me go get them. I should get some calipers too. But yeah, it does look like that. So let's just keep it pushing. All right, so then so we're gonna extrude this by 7. So that's the bearing. So now we just want to. So let's take this, rename bearing, rename bearing, rename stand. Insert bearing, mate this to this, and this is going to be fastened. That's true. So now what we need to do is we need to build one of the arms, and maybe we could read a little bit about what lengths are good. I mean, I don't think it matters, but it seems like people don't typically use equal leg lengths. Maybe I will. This is all that's written about the double pendulum? That seems kind of shocking. Okay, so let's just make them equal. So now we're gonna make I thought there was a way to quickly rename without having to do this. Okay, so actually I want to do this in place. Okay, so now we're gonna sketch on here. Wait, this is the assembly. Oh, crap. Maybe I should have... Whatever, we're gonna sketch on here. Do we have this center point? I don't think so. Alright, so now we want to do this. And we want to make this 8. I don't know if we want to undersize it. We'll find out. I mean, I'll do a couple of prints on this. Alright, so we want to extrude this maybe at least 7. Okay, so let's make it 7. Wait, hold on. But it needs to go the reverse direction. And it's a new part. And then we want to sketch on here. Oh, no, not extrude. We want to sketch on here. And we want to do this. And then we'll just make it line up. How about that? So let's just say this is that. Okay, now we're going to take this whole thing, extrude it. It's only going to, let's see, part 3, add to part 2. It definitely doesn't need to be that big. Probably 10 is good. I also don't feel like it even needs to be that big. Should we be worried about friction from there? If we make this extrusion, here's what we're going to do. Second end position. And this is going to be 0.2. So now there's a slight gap in there. Okay, so now we can just sketch on here. You should just be able to do so this makes a closed curve, so that's good. So now, but what we want is, I guess, that this line and this plane are midpoint. Midpoint requires a point and a line. Okay, why don't we just do this? So the total distance from here to here is 20. So we're going to make this, so we're going to do, let's just make this 5. We can make it thin. So this is going to be, this is going to be 10, this is going to be 7.5, right? That doesn't look right. Oh yeah, it does. Okay. And then the length of this, do we want a weight at the end? I think we need a weight at the end. We could just put a, all right, for right now, let's just, let's make it 35. Okay, so now we just need to extrude this by flip it 5. So, but what we actually want is we want to take this and we want to let's say like this needs to be 22, and this needs to be and we're gonna can I change these to Q's? Okay, that's nice. So now I should be able to select this as part of the extrusion. Wait, but we can't do that. And then we also need it to be 7. Okay, so we're going to take this extrusion and we're going to make it 7. And then we're going to make this extrusion and we're going to make it 7. Okay, so now bearing fits in there. And now we should be able to use the exact same part, right? So now we want to make this no, not that. Extrude 2 like 150. Okay, so now what we want to do is in here, insert, stand, part 2. Okay, then this, okay, and now we would just want to copy this, right? So first off, we want to insert another bearing. And then we want to insert, we want to copy this. We want to insert, why don't we just do this? What the hell? There we go. And then I think we want to do this. But maybe we want to flip it. And offset it like that. And then we're just gonna, so you need 3 bearings. All right, this looks pretty good. The only thing is we wanna make it look pretty now, but we're gonna insert one more bearing. I like it. I think it looks good. We're gonna make this stand a little bigger, maybe. It's a shame because I have so much stuff to print that I can't actually print this for a while. But let's just do this. Aggressive. Let's just make the This one doesn't need to be 65. Oh. Actually, what we want to do, that's 10. Does that mean that you take this edge and you take this? No, that's not what I mean. I want to know. There, that's what I want. Wait, X is 13? No, Z is 10. Wait, how is X 13? Shouldn't X also be 10? I think it looks good. I feel like I could disable this last fillet, though. Nah, it looks better with it. I feel like it's gonna, I feel like the base needs to be wider. Let's make it 75. And then I'm also gonna actually make, that's 7.5. I'm gonna make this 10. Oh, we definitely need to fillet this too. So wait, so in this fillet, we're gonna add this and this. I think I'm gonna add just a pair of mounting holes, just in case. So obviously go before the fillets. Honestly, why don't we just do this? Actually, no. Let's wait. Let's go after the fillets. Or we could just that's just in case that it's not strong enough. Because I feel like the second that you get some weight on here, this thing is gonna tip over. Or like you're gonna push this thing, and then it's gonna swing in some weird way, and it's gonna fall over. But I like the ratios. I like the height of this thing. I like the distance from here to here. I feel like this thing is turning out really cool. And I like that I used the same part so that you could hypothetically add as many linkages as you want. This is clean, bro. This is clean. The next step is to make it on a set of linear rails, and then have a motor get it so that you can invert the double pendulum. Because one of my favorite freaking things of all time is that is the triple pendulum. Is it this, or is it? I think it's this video. This is probably in my favorites playlist. But it is so cool. It shows basically that there's some number of wait, I don't know if it's transitions or if it's the number of unique states that it can be in. It's kind of an interesting combinatorial problem. But this thing is so freaking cool, man. So anyways, that would be the next part of this. I wonder if they're just using standard bearings. I wonder how they machined this. Are they equal lengths? It looks like this last leg is longer than the yeah, see, it seems like they get progressively longer. I wonder why they do that. Sampling time is 1 millisecond. You can buy them? Wait, you can buy them? I don't know. This truly is the world's first video. Great. Okay. Oh, yeah. Damn. I feel like this would be such a good project to learn control. Because I don't know any of that stuff. Dang, man. It's actually so impressive how these trajectories. Wow. I mean, it does it so efficiently. It's not like it has to come to a... Yeah, so it's really the transition planning that's so cool. Well, anyways, I mean, I can... I'll just throw this in the... I'll probably do a second video where I might print them off stream just because it's like, who cares? All I'm doing is exporting two models, printing 2 of these, printing 1 of these. But maybe I'll do the assembly and then the testing on stream. So that'll be part 2 of the 1-day builds, making it probably a 2-day build because I got way more important stuff to actually print, which is this and this. But I can throw this up on Thangs or something. But since it's Onshape, I feel like I'll just put the Onshape. I'll just put the Onshape link in. So I think let's see. This document is private, so we'll just make it public. wait, let's do link sharing. Okay, so anyone with the link can view and export. So then I'll copy this and I don't know, can I actually, oh wait. Okay, so yeah, so that's the, okay, well let's also do an analysis of print time. So let's open up a new Bamboo Studio because I want to keep this one. What? All right, so let's get the export here. So we're going to export basically part 1 and part 2. And then we got to freaking unzip it. It's such a pain in the butt. So let's just make 3D, let's make a new folder. Double pendulum. Okay. Okay, so we got a new one here. Take this, go back to here. All right, so we could also do a fillet along this, right? I can't tell. Does that look nicer than this? I feel like that looks gross. I don't like this. Okay, so an hour of printing, and then presumably this will not be. We'll probably have to make the because what? So this is that, and then what is this exactly 8? Well, okay, we'll have to probably do some tuning of the so maybe I should do a little couple test prints before I print this whole thing. So maybe I'll just print without the stand just to get a sense of the fit. But other than that, this is pretty good. Costs you $1 to make a fun toy. $1 plus well, $7, but 7 over 20, 35 cents times 3, $1. Okay, so it's like $2 for this toy. That's honestly not that bad. Obviously, you need the upfront cost of the to own a 3D printer. Let's see, what does it cost to get this printed? Can I change quantity? Presumably there'll be a quantity thing. Okay, so it's SLA on resin is the, okay, quantity 2. That's actually really high. $20? Oh, no, shipping, that's shipping estimate. $10 for this? What if we do FDM? It's still pretty expensive. I didn't realize how expensive it is to order 3D printed parts. Why is it so expensive? That doesn't even make sense. Okay, let's do the same setup that I have. Build time, you can't select anything else. That is shocking. All right, what if we wanted SLS made? Wow, that's actually crazy. Okay, wait, hold on. Let's go back to SLS. Is it updating the price? I can't even tell. Okay, so yeah, it's more expensive, but like not that much more expensive to get it in in nylon SLS, which should be strong. What is MJF? Multi-jet fusion?
Multi-jet fusion. Today we're talking about what multi-jet fusion is and how it works. Let's get started. So what is multi-jet fusion? Multi-jet fusion is an additive manufacturing technology designed by HP, with its first printer being released in May 2016. MJF is part of the powder bed fusion family that also includes SLS and binder jetting. It produces detailed functional prototypes and end-use parts for low to mid-volume production. Multi-jet fusion printers produce plastic parts that are relatively strong, detailed, and have near mechanically isotropic properties. On top of that, MJF is fast, strong, detailed.
Nearly isotropic properties? That's shocking, man. It is shocking. Okay, I'm gonna get some more coffee and take a piss. But yeah, so I just want to leave this up. Pretty cool. Okay, I also thought of something great. What we're gonna do is we're also gonna look at the cost to CNC machine it, and we also are gonna we'll see what the cost is for SLM. Yeah, see, SLM is expensive. That makes sense. Oh my god. Yeah, no freaking way. But now I'm curious because we should. Actually, wait. I want to make sure though. If I do this to 1, does it go down? Okay, yeah. So that's the total. That's good. Um, it's making me do it again. So I think what I would need to do to so interestingly the material is not that I'm surprised though because they must have to draw a bounding box. Yeah, so this is the bounding box. Okay, so maybe we should do a second version of this. What we're gonna do is we're gonna just I want to split it into 2 parts because I want to see how much the cost goes down because the thing is there's going to be a lot of waste here. But if you cut out this part, then presumably this waste is at least a little bit less. And then yeah, it's so interesting, right? Like doing metal stuff that's going to be machined as opposed to additive. It's like I think so much more about the material cost because you have to implicitly draw a bounding box. And that's like the only way to do it. Still though, that's a heavy, heavy price. What about plastic CNC? That's interesting. Still plastic. I mean, I guess the reason why it's so high is mostly just because you need to use their CNC machine. Is the supply of CNCs is the supply and the capital cost of CNC machining is just high, but it's not actually because like okay, yeah, if we do the breakdown, the material cost, okay. First off, that doesn't I don't know. That doesn't okay, but let's look at this one. The material cost has got to be exactly. So the whole cost is just basically letting me use their machine because there isn't that many. I would love to see a JLC. Let's go to YouTube and look at JLC CNC and just see what kind of dude, look at that factory. It's full of freaking CNC machines. That's so badass, man. Okay, see, that's actually not that many though. 190 CNC mills. That's not like it's not like in the thousands. What machines are those? Actually, yeah, who are the worldwide biggest CNC mill manufacturers? Worldwide biggest CNC mill manufacturer. Who sells the most? By revenue? I don't know. Dude, DMG Mori's Instagram page is hype. That's interesting. It's dominated by Germany and Japan. That is super interesting. So there's no Chinese CNC makers? Whoa. Dude, I bet that, though, I mean, like, gosh, if you're in Shenzhen, though, like, you just have all the parts available for you. Where's JLC? Uh, yeah, but what I want to know is where is this company? Okay, let's just go to their website. They must have an about page, right? They gotta be in, wait, what? That's not right at all, dude. In Hong Kong? Yeah, Shenzhen. I mean, that's gotta be where, like, why would they be anywhere else? That's so awesome, dude. They have the whole maker ecosystem there. They got everything, bro. All right, let's see what machines do they have. MKT650. MKT. Oh, is that a G? No, that's a 6. Dude. Oh my god. That's so awesome. Huge gantry, bro. Yeah, actually, they didn't even say, because, like, that's the interesting thing, is, like, there's no way that, like, I don't know. It just seems like you very rarely, if you were to try to scale a business like this, would you want to get any 3-axis, because the generality you get from 5-axis, the class of parts that you can, like, okay, if you were to take the class of all step files, all valid step files, and I mean, you just cover such a bigger portion of, okay, all of the step files that have ever been made and manufactured, the portion of those that you can make on a 5-axis versus a 3-axis, it's like just doing a chamfer, it's gonna be, or doing a fillet, it's gonna be hard. So what are we looking at here? What do they have? Yeah, that's interesting, right? Like, it's weird though, because when you upload these step files, it doesn't even let you, like, choose whether or not it's a. So I really wonder what goes into the pricing algorithm here. I mean, they must. I mean, if you're gonna put your money on, because look, like, for them, the risk that they take on is kind of high, because they don't know if it's actually, like, no human has looked at this and been like, how hard is this to assemble or manufacture? So there must be some level of complexity going on with this pricing, because it's like, oh wow, and that makes it way more hard, because now you have all this labor that goes into reading a technical drawing. But that's actually interesting. They probably don't want you to do modeled threads. They probably want you to, because modeled threads I don't know. Maybe you do want to model threads. What is this? I don't know what this is. The tightest tolerance. I mean, it's actually interesting because in a lot of ways, what you want is not just a step file, but you really do want, I mean, what in the back in the day, I guess, would be a technical drawing. But you want to carry some information about tolerances in the CAD, I would say. Please upload the annotated 2D drawings. There's no Wikipedia page? It's kind of funny. What a beautiful little object. Dude, I want to see that thing. Hey, he's not using a mic. What the hell? What the hell, bro? Quality checks, he's using a freaking caliper. That's not a precision tool. I don't know. Maybe there are precision mics or precision calipers, but that guy's got to get a mic, dude. What the heck? Is this one of these? Is this one of these shots where they superimpose? Do you think he's actually looking at this, or this is stock footage, and they just superimpose the website? I mean, I don't know. Dude, JLC is so cool, man. All right. So I guess what is the conclusion here? The conclusion is basically that yeah, I wonder how toys are. I wonder how toys are. So is this the CNC? Yeah. So we would want aluminum. Let's see. Is they don't do steel? Now that's interesting. They don't do steel. Is it send cut send? No, but this is just. Oh yeah. We just do that. Now that's crazy, bro. Let's check in on this print. Let's just see. Is this the right one? I think so. No, do you see that? Do you see that? Ugh, it's foam, bro. It's totally broken. Something is going wrong. I'm gonna have to. Okay, well, it's obviously not worth fucking. I'll show you guys. Ugh, come on. Okay. So, here's what's going on. Do you see how light that is? See all this surface finish? Same with this worm. You can hear it just totally crumbles. And it's not because it's like slightly overhung. It's because it's clogged. So I guess now's a good time to end the stream. I feel like the double pendulum thing is actually pretty sick, but this having to clean the nozzle, I'm definitely gonna buy two more nozzles. I have the point. Maybe I'll just switch to that. No, but then, dude. Okay, I think I'm gonna get a hardened steel 0.6 and a hardened steel. Didn't they come out with a new nozzle actually? Maybe I'll get their diamond or whatever. Nah, but I'll probably just get the 0.4 and the 0.6 hardened steel. I feel like it's kind of cheating to just buy the new ones instead of like thoroughly cleaning it, but at the same time, it's like $20, and I need to get more filament anyways. Anyways, here's some satisfying. Terrible. Terrible. It's like paper. Anyways,